Bismillahirrahmanirrahim. Dear students, hope you are doing well and you are spending your time in your studies as well. I am Muhammad Burhan. I am here to give you a lesson today on an interesting lecture or very important lecture of simple harmonic motion. Before starting that, what we have done so far is we have just elaborate an example of simple harmonic motion. The example was about the mass spring system, a mass which was attached with a spring, and I have put some other videos so you can see these video lectures to understand further well about your topic. So let me check everything is appropriate. Now let's start with our today's lesson. Our today's lesson is another example of simple harmonic motion, and we will understand that how simple pendulum behave as a harmonic oscillator. So motion of simple pendulum so we can write here as execution of simple हार्मोनिक मोशन। जैसा कि हम पहले पढ़ चुके हैं कि एक सिंपल पेंडुलम बिहेव करता है ड्यूरिंग इट्स मोशन, अपनी मोशन के दौरान, एज आ सिंपल हार्मोनिक ऑसिलेटर। सो आज हम स्टडी करेंगे कि किस तरह से एक पेंडुलम मोशन करता है और मोशन एग्जीक्यूट करता है, सिंपल हार्मोनिक मोशन। लास्ट लेक्चर में हमने ये सीखा कि सिंपल हार्मोनिक मोशन एग्जीक्यूशन के लिए एक्सेलरेशन मस्ट बी डायरेक्टली प्रोपोर्शनल टू द डिस्प्लेसमेंट एंड इट्स डायरेक्शन इज टुवर्ड मीन पोजीशन। सो फॉर द केस ऑफ पेंडुलम, for the case of pendulum, we consider a bob, and the important thing is here we ignore air friction को हम यहाँ पर इग्नोर करेंगे, एंड द स्ट्रिंग जो कि अटैच है इस बॉब के साथ इज massless। So these are our condition for simple pendulum. So we have considered a simple pendulum. We will draw another diagram of simple pendulum. So this is the mean position of simple pendulum when we have not applied any force. When we have not applied any force. So this is the case when there is no force acting on a pendulum. So we will say this is the mean position. In our all three examples which we have done so far, we have considered the mean position of a system when there is no force applied to the system. So let's call this position O. So we will see what forces are acting at that point. Forces acting at that point. What point? The point is mean position. मीन पोजीशन पर कौन सी फोर्सेस एक्ट कर रही हैं इस टाइम पर? सो देयर इज़ अ फोर्स ऑफ वेट विच इज़ इक्वल टू mg, where m is the mass of Bob and g is the gravitational acceleration, because in this case the acceleration acting on a body is gravitational acceleration. So why this bob has no motion? इस बॉब की मोशन इस पॉइंट पर क्यों नहीं है? Because both forces mean which are two forces are acting at that point. One force is the force of tension. I'm designated is with small t in subscription, and other force is the force Fw, the force of weight, and the tension force. These two forces are being cancelled at that point. Okay, next, what will happen if we just move that pendulum from its main position? What will happen? The pendulum, this is the main position, and this is its extreme position. We have applied some force and make a transition of this bob from its main position towards extreme position. Let's say this is A. A is extreme position. Here I want to include one thing, that while you are attempting your exam or attempting a question in a test, so just you need to know how to elaborate your question and the figure. Then if you just know the method to elaborate your question, then it will be really easy to learn a long question, learn as a paper point of view. So this is the extreme position of simple pendulum, this is the mean position of simple pendulum, and we want to check here forces acting upon the pendulum, definitely at extreme position. So let's check these. So this is the component, this is the weight of this bob, same as which was acting at mean position, which is mg, and cancelled out by the tension T. Here this weight is not straight. Here there is a small angle which is being made by the string at the connecting point. So here we cannot write the weight only by mg. What we have to do? Because here the value of weight is not equal to mg because of the direction. So let's see what happened. We have to make the components of weight. Here we have to make components of weight. So there are two components. One component is mg cos theta, and the other component, which will be straight, is mg sine cos theta will be that component, and this will be mg sine theta, because this is our base and this is our perpendicular, and this vector is being converted into two components. One component is mg sine of theta and the other component is mg cos theta. So as you can see, I am going to draw that figure over here. The component form, this is the bob, this is the straight vector which needed to be converted into its components. इसको हमने कंपोनेंट्स में कन्वर्ट करना है. ये कंपोनेंट है जो कि इस डायरेक्शन में है, एंड दिस इज़ द कंपोनेंट विच इज़ स्ट्रेट विद द स्ट्रिंग. सो दीज टू forces, component mg cos of theta and the tension, they are being cancelled with each other. एक दूसरे को कैंसिल कर रहे हैं. सो बॉब के ऊपर जो कंपोनेंट ऑफ फोर्स एक्ट करेगा वो कौन सा है? दिस वन. दिस कंपोनेंट विल एक्ट ऑन द बॉब. सो अंडर द एक्शन ऑफ दिस कंपोनेंट विच इज mg sine of theta, yes you are right, mg sine of theta, this will lead the bob toward its mean position. Okay, so the pendulum, the bob of the pendulum will move from extreme position A towards the mean position, which we have designated as O, and it will not stop here. Can you tell why this pendulum is not going to stop in here? Because due to inertia it will not stop in its mean position. It will go towards the extreme position, same as it that we have learned in a mass spring system and the example of ball bearing in a bowl. So the component of force, which is F is equal to mg sine of theta, is the component that will act as a restoring force. Storing force for the particular case of a simple pendulum. So hope now by listening this lecture you are able to construct the component of force, weight force, and find out what are the forces being acting on a simple pendulum for an ideal case. Ideal case means that the string is massless, unstretchable, or there is no air friction is acting on the system. So these are ideal case. I am also going to upload some other videos, some animated videos, which will help you to understand more about the motion of simple pendulum. Thank you so much. Take care of yourself. Allah Hafiz.